Good afternoon. Today we're going to review Unit 7, Right Triangles and Trigonometry. You need to have your calculators ready and your pencil and paper ready. Again, no work, no credit. So our first problem here asks us to find the value of x. Now with this value of x, a couple things are going on. One, I have a right triangle. When I have a right triangle, there's only going to be two ways to be able to find something, either A, using our trigonometric ratios, or B, using Pythagorean Theorem. Because I'm looking at a side, and I'm given the other two sides, I'm going to go ahead and use Pythagorean Theorem. So the Pythagorean Theorem tells us that c squared equals a squared plus b squared. So how do I know who a, b, and c are? C is always directly across from my right angle. It's not that A and B don't matter, it's that A and B can be either leg. We call one A, we call B, because mathematically they work the same in the equation. So now I'm going to substitute in my various sides. Oops, that's x squared. Now I'm going to go ahead and square 19. Subtract 81 from the side. So 280 equals x squared. Now there's two answers that you can have to find x squared. I can either have a square root answer, because to get rid of my x squared, I have to take the square root of each side. So the square root of 280 equals x. If they want your answer in simplest radical form, you would then have to simplify that radical. I have told you that you can go ahead and make them decimal. So we're going to go ahead and go with that for this one because we'll simplify a radical later on. So now I'm going to go ahead and I'm going to take the square root of 280 and I get 16.73. I'm going to round to the nearest hundredth to get my value of x. I could have easily simplified this radical and that could have been my answer as well. Taking the Pythagorean theorem to the next step, we're going to talk about how you can determine whether a triangle is an acute triangle, a right triangle, or an obtuse triangle. Those are the three theorems that go along with the Pythagorean theorem. First, to determine if a triangle is an acute triangle, the theorem says that c squared has to be less than a squared plus b squared combined. We already know that if it's a right triangle, then the Pythagorean theorem holds true, that c squared is equal to a squared plus b squared. If it's an obtuse triangle, the theorem tells us that c squared is greater than a squared plus b squared. So to go ahead and determine whether this is a right, acute, or obtuse triangle, I'm going to have to do some math. So first, how do I determine who a, b, and c are? C is always my longest side. A and B, interchangeable. So I know that c squared is having some kind of relationship with a squared plus b squared. And that relationship is going to determine whether it's acute, right, or obtuse. So I have 11.9 squared. I'm going to have 6.3 squared plus 8.3 squared. So now I need to go ahead and do some math. 11.9 squared gives me 141.61. 6.3 squared plus 8.3 squared gives me 108.58. So now, looking at these two numbers, 141 is greater than 61, which means c squared is going to be greater than a squared plus b squared, which means I have an obtuse triangle. Obtuse triangle. Okay, the third thing we're going to talk about today is the geometric mean. If you recall back from Unit 6, the geometric mean by definition said that x equaled the square root of a times b, a and b being my two numbers involved. So in this case, x is going to equal the square root of 4 times 13. So I just take 4 times 13, and I get the square root of 52. Now with the geometric mean, we had all of our answers in simplest radical form. With that, I'm going to now have to go ahead and simplify this radical. So if you recall, I need to find its prime factorization. I could do it so quickly because I know it's 4 times 13 and 4 is 2 times 2. So I can do it quickly. 2 to get out of my house, 13's left. Voila, I have simplified my radical. Okay, the next thing we're going to look at today is taking that geometric leg theorem and that geometric altitude theorem and put it together to find the missing side of basically a right triangle inside of a right triangle. If you remember, the two theorems were for the geometric mean for the altitude and the geometric mean for the leg. And remember, I told you the easiest way to do that is to set up the chart. The chart organizes the information because they're similar figures. Therefore, I'm going to set up a proportion. So making my chart will help me to be able to determine where things go so I could easily set up a proportion. So I made a 3 by 3 table. I have the small, the medium, and the large triangle. Then I have my short side, my long side, and my hypotenuse. Now, as we discussed earlier, the bigger triangle is the easiest one to spot stuff on. I have my hypotenuse being 12. My short leg is 6. I could find my long leg using Pythagorean Theorem, but I don't know if I need to, so let's not do extra math if we don't need to. Certainly we could do it quickly, but I'm going to hold off finding it for now because I might not need to find it. Here is my small triangle. How do I know it's smaller than the other one? What you have to realize with the small triangle, and what you have to realize in general, it doesn't matter who you really call the medium triangle and who you really call the small triangle, as long as you're consistent in how you're calling them so that you can go ahead to set up your proportions. With calling this my small triangle, we know the relationship as this is the long side of the small triangle, but it is the short side of the medium triangle. That's how that geometric mean overlaps. The small triangle, it's the long leg. The medium triangle, it's the short leg. So just so we know how it sets up inside of here. So I know then that A on my small triangle is going to be the short leg because the long side is going to be the altitude. Then I also know that my hypotenuse is 6. How do I know that? Because it's directly across from the right angle that's sitting right there. So as you can see at this point, I don't even need to go ahead and find the missing pieces because here I have my proportion already set up. A over 6 equals 6 over 12. Now all I'm going to need to do is cross multiply and divide to find A. So here I have 12A, sorry my A looks a little bit long there, equals 36. Divide both sides by 12, A equals 3. Now B is a little more complex. I've got an X, I got a Y, and I got a Z. So the first thing I'm going to do is I'm going to set up my table. Why? Because it organizes my information. So I'm going to make my 3 by 3 table. My small, medium, large triangle, short side, long side, hypotenuse. Sorry. Bless me. So now, my hypotenuse of my long triangle is 16. My long leg is 14. I don't know my short leg. My medium triangle, well, I know with my medium triangle that, remember again, this is my my short side, and this is my long side of my small. So my short side is Z. My long side is X, and my hypotenuse is 14, just to organize my information. And then on my little triangle, my short side is y, my long side is z, and I don't know my hypotenuse. So now I can start setting up some information to be able to go ahead and find what's going on. Right away, we notice we got a proportion here. So I have x over 14 equals 14 over 16. So I can quickly find x by cross multiplying. So 16x equals 196. Divide by 16, x is 12.25. So I found my first variable. Now, I know that x is 12.25, so I know that this piece right here is 12.25, which means that this much of it is 12.25. I can go ahead and find y now by a simple subtraction. Because I know that the whole piece is 16, I know that this is what x equals, y is the missing piece. So 16, the whole piece, equals y plus x. We know that x equals 12.25. So 3.75, when I subtract both sides, is my value for y. So y right here is 3.75. X, when we found it, was 12.25, which brings us to proportion number 3. Here is how I find z. Z is y over z equals z over x. I know that y is 3.75. I know that x is 12.25. So now I know I can just cross multiply, so I get z squared equals 3.75 times 12.25. So it's 45.9375. And then I know that I need to take a square root of both sides. And I know that Ms. Singletary said we could have decimals for this, so that's okay. But when I go to take my square root, I'm not going to round this number. So I'm either going to type the whole darn thing in, or I'm going to remember that I can recall a number. If you remember that, looking at my calculator, I can take a square root and recall that number. So when I do that multiplication that's sitting in my calculator, I can take my calculator and remember I can go second square root to get my square root, second, and then down here at the bottom, at the way bottom, is the button right here. When I hit the second, it recalls the answer, so that answer comes back into here. So when I hit enter, I can then round it to 6.78. So as a reminder to recall an answer, to recall the answer, I just come back in and say second square root, second, and it recalls the answer under this button right here. And then I just hit my enter. We don't want to round early or we get a rounding error. We do that a lot when we have sine and cosine. We don't want to get a rounding error. All right, number 5, we want to find the value of the variable. Our answer needs to be in simple, radical, or simplest, radical form. All right, I have a special 45, 45, 90 triangle. So what do I know about my 45, 45, 90 triangle? First of all, in just the generic sense of my 45, 45 triangle, I know that the relationship that they tell me is that each side is x and that my hypotenuse is x square roots of 2. So now I'm going to come back and I'm going to try to solve this equation here. For benefits of not getting confused, I'm going to go ahead and put my generic pieces in, my x, and x squared roots of 2, but I'm going to call them n. Why? So we don't get confused if it's the x I'm looking for or if it's the x in the generic. So these are my two legs. Oops, this doesn't call it n, and I made it an x. And then I'm going to make my hypotenuse, which is across from over here, n square roots of 2. So now when I'm going to go ahead and try to find what x is, x equals n square roots of 2. It equals its relationship. N is 3 square roots of 3. So it equals 3 square roots of 3 times the square root of 2. Numbers multiply with numbers, so I have 3. Radicals multiply with radicals, so I have the square root of 6. It does not simplify. I am done with 3 square roots of 6. The next special triangle we have is our 30, 60, 90 triangle. Again, our answer has to be in simplest radical form. So now again, looking at my generic 30, 60, 90 to remember my generic. If you remember back in the beginning, we said that from the 30-degree angle, it drives my master, my N. He's my driver because every relationship's built off of him. My hypotenuse is 2 times that angle. My long side is the square root of 3 times that angle. So when you find the angle across from the 30 degree, it helps you. I like to go ahead and write it on my master over here too. Again, I used N because we have X's and Y's we're looking for. So across from my 30 is my generic, then my hypotenuse, and then my third side. So now I want to find out what N is so I can find out what X and Y is. So the first thing I'm going to do is I'm going to set my relationship equal to the side. So 2N equals 6 square roots of 7. I've got to pull out what half of that is so I can work with it. So now, if 2N equals 6 square roots of 7, I'm going to have to now divide it by 2. Means my numbers divide, so I end up with 3 square roots of 7 is what N equals. That's my driver, N. But now, that's not what I'm looking for. I'm looking for what Y equals. Well, Y equals N, which equals 3 square roots of 7. So there's my first answer. Then we know that X equals N square roots of 3. So that's 3 square roots of 7 times the square root of 3. Because N is the 3 square roots of 7. So that piece right here replaces that piece right there. So now, again, numbers multiply numbers. Radical multiplies radicals. So X equals 3 square roots of 21. What happens when I don't have Mr. Special Triangle? Well, when I don't have Mr. Special Triangle, I have to use our trig functions. So what are our trig functions? That's my Sohcahtoa. Sohcahtoa is an acronym for the trig functions. Same thing as I said, some old horse came a-hopping through our alley. Same thing as Sohcahtoa. It just keeps straight who's going to divide who and who's going to make whose fraction. It means sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So when I come back here and I look at my picture, I first need to figure out what am I looking for. I'm looking for X. So now X and 16 are 2 legs. If I have 2 legs, it's always going to be tangent because sine and cosine deal with my hypotenuse. So now I know that the tangent of angle 33 degrees equals my opposite over my adjacent. So here's my angle. That is my opposite 16. My adjacent or next to angle, or not side, sorry, is X. Now I need to mathematically solve this. I need to get X out of my denominator by multiplying both sides by X. I need to get rid of tangent with my X. So X is going to equal 16 divided by tangent of 33. And I rounded to the nearest tenth. 100th, excuse me. Now, I have to make sure my calculator's in degrees. Why? Because I've got 33 degrees here. So remember, you go to mode, and then you make sure it's in degrees, not in radians. Need to convert it over. It changes, it affects nothing in my calculator except my degrees. Except for my sine, cosine, and tangent, sorry. Then anything else I do, it's not affected. So as soon as you walk into the class, change it. As soon as you walk into your SOL test, change it. So how is number 8 different? Number 8 is different because now I'm going to use the calculator to approximate the value of x. With that, I'm looking for an angle. We still have our Sohcahtoa that sets up our how our trig function should look. But when I'm looking for the angle, we're looking for the inverse trig function. So I still set it up the same way, but in my last step, I'm going to take the inverse of that angle. So now, first I have to figure out which one of these I'm going to use. I have angle x. I've got an opposite over a hypotenuse, so I'm going to go ahead and use my sine. So the sine of x degrees is going to equal my opposite over my hypotenuse. Now, because I'm looking for the angle, I do the inverse trig function of this ratio equals that angle. So now I take my calculator, sine -1 of 12.1 divided by 15.7, and it gets me 50.42 is what x equals, or 50.42 degrees. Either one is correct. Either one is correct. Number 9 takes us on a little bit of a word problem. I have a ladder that's leaning against a wall that is 21 feet above the ground. Find the measure of the angle formed by the ladder and the ground. So I'm also finding here, the same thing I'm finding here is my angle of depression. It's the same kind of idea. I have my house, which is 21 feet from the ground, above the ground. I have my ladder on this side here that is 33 feet long. And I want to know what, and it's going to make a right angle against the house. I want to find the measure of this angle formed here. If you were talking about being on top of the ladder, it's the same thing as finding that angle of depression. Sorry. That remember with the angle of depression, you're looking straight out, and it's the angle formed if you see a bug on the ground. That's the angle of depression. The angle of elevation, if you remember, says that I'm looking straight out, and now I'm looking up at something in the sky, and therefore it's my right angle, and it's this angle right here. It's the angle of elevation. What you have to remember with these two angles, and this is the important thing, this is with the soccer ball in the homework, is that when I'm looking at these, they form basically a square, or a rectangle, actually, probably not a square, a rectangle. And so here, that angle is the same angle as this angle here because I have parallel lines on the top and the bottom. So they match. Same thing here. If I'm looking here, it's the same thing as that angle there because my sides are going to match. My sides are going to be congruent either way you look at it. It's just the properties of a rectangle. So it doesn't matter how you draw that picture. You just got to make sure you got the right angle going on. And that's what happened with the soccer ball. You found the angle of depression, but that's where the foot hit the foot making the angle going up does the same thing from the homework. So just be aware of that because there is an angle of elevation or depression on your test. This does not have to do with that, but I want to make sure you understand that. So now coming back to this problem here, I'm trying to find this angle. So the angle that basically the ladder is elevated off the ground if you want to use the same terminology. So here, if I'm looking for this angle here, what's it going to be? It's going to be either sine, cosine, or tangent, and the inverse because I'm looking for the angle. So here, I'm looking for this angle here. I'm now going to change it to x. So now I've got an opposite over hypotenuse. So SOA is my opposite over my hypotenuse, so the sine of x is going to be 21 over 33. So again, I got to use my inverse of the ratio, gives me my x. So I'm going to come to my calculator, all calculator work. (39.52 degrees). This next one says to solve the right triangle. To solve the right triangle, you're going to find the missing pieces that are here. So we're basically finding of our angles, the measure of angle C. Of our sides, AB is missing and CB is missing. So first, how do I find the measure of angle C? Well, we know any triangle, the three angles together equal 180 degrees. So we know that the 43 degrees, or the measure of angle A, plus the measure of angle B, which is 90 degrees, plus the measure of angle C, which is, we don't know, equals 180 degrees. So the measure of angle C is just 180 minus 43 minus 90, which is 47 degrees. So I have the measure of angle C. Now I'm going to go ahead and I'm going to try to find AB over here. So all I'm given when I'm given AB is I'm given an angle measure and I'm given a side. So I'm going to use some trig function stuff. When I only have one side and I have one angle, I'm going to have to use some trig stuff. So I have the adjacent is AB over my hypotenuse, so it's going to be the cosine of 43 degrees equals my adjacent, which is AB, over my hypotenuse. So now to solve it, I'm going to multiply both sides by 8. So making sure my calculator's in degrees. 5.85 is my length of side AB. Now to find side CB. CB is over here, so when I'm looking at that, oh, that's going to be from my angle, my opposite over my hypotenuse, because I have a hypotenuse. So it's going to be the sine of 43 degrees. It's going to equal my opposite, which is CB, over my hypotenuse, which is 8. So 8 sine of 43 degrees equals CB. And I rounded to the nearest hundred, so it's 5.46. So solving the right triangle, when you're solving the triangle, the right triangle, you're finding the missing sides and you're finding the missing angles. On our test, we will have one that has missing sides and angles. Last but not least is our friend here. I don't have a right triangle. When I don't have a right triangle, there's only two things that I can use to solve it. The law of sines or the law of cosines. With that, I want to kind of recall, how do we know who does what? When I have a triangle ABC, it is not a right triangle. The side opposite of A is little a, the side of opposite of B is little b, and the side opposite of C is little c. So now I'm given some information here. I'm given that C is 22. I know that the measure of angle C is 39 degrees. I know that B is 31, and I want to go ahead and find the measure of B. Since I'm given two sides and one angle, I'm going to want to use the law of sines. Why? Because I always try to use the law of sines first because it's not as complex of an equation. Is law of cosines hard? No. but you're going to have to do a little extra math with law of cosines. Law of sines just comes up to be that ratio. Law of sine says the sine of A over little a equals the sine of B over little b equals the sine of C over little c. So right away I know that I have the sine of 39 degrees over my side, which is 22. I know here, I don't know what that angle is, but I'm going to find it because an inverse trig function will do that. And I know that the side is 31. I now have a proportion. I don't even have to involve side A. To solve the proportion now, I'm just going to cross multiply. So I like to put the number first. So it's 22 sine of B equals 31 sine of 39. So to get rid of the 22, I have to divide it on both sides. So the sine of B equals 31 sine of 39 degrees divided by 22. Now, just so we're on the same page, this is what I'm taking the inverse trig function of. I need to make sure I lock my numerator and lock my denominator. This is what I'm going to want to recall the answer. When I mean lock my numerator, I like to put this into the numerator. I hit enter. Then I hit divided by, then I hit 22. So I get a really long number, and I'm going to write it down, but I'm not going to use it because I'm going to recall it so that I don't make an error. Otherwise, I'm going to have to type that whole bit of garbage back into my calculator because it even goes on past that. But I'm going to type all that back into my calculator because now, remember, I'm doing the sine -1 of this big, long dealio thing. It's going to be angle B's measure. So I get it out. So on my calculator, I have the answer right there. So all I'm going to do is do sine inverse -1. I'm going to recall the answer like I showed you by hitting second and then hitting that button. Recalls my answer. When I hit enter, I get angle B, or the measure of it, equals 62.47 degrees. And that's how I pull out the degrees. As I mentioned in class, you probably have a law of sines on your test, not a law of cosines. But that doesn't mean you don't need to know how to do the law of cosines, because we practiced it several times. Law of cosines uses the same information here, except for it's a little bit longer formula. But your test will have a law of sines on it. So if you're watching your video for your review, lucky you. With one other thing I want to point out, this is a nice review chart of everything we've done. Here again, LOC is law of cosines, and you can see it gets to be a little bit crazy with your little formulas we have in there. Law of cosines is only used if law of sines cannot be used. And as we've mentioned before, you can do law of sines twice if you wanted to. They probably won't let you do that in math analysis, but you could do law of sines twice and then get the same answer as using a law of cosines up front. So always use law of sines first. This page is available if you want to get it right here. I will also put it as a study guide on Aspen for those who want to look over it. It just breaks up the different topics that we're doing. Thank you guys, and have a great night.